Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic demonstrating the converse of the Pythagorean theorem. So converse being the result from the Pythagorean theorem we're going to use to prove the basis for it. So we have two triangles and we know all three of their side lengths, and we're going to use these pieces of information to figure out if it's a right triangle or not. Remember that the Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. So now we're going to do it backwards and figure out if a squared plus b squared equals c squared or not, and if we'll use that to interpret our answer. So looking at this, so they already identified a, b, and c, but you could do that yourself. Remember, c just has to be the largest of the three numbers, so in this case 12, or in this case 20. And then they actually already plugged everything in, so we just really have to work it out. So they're really kind of handing this one to you. So it's more about the interpretation than the calculation. So we have 8 squared, which is 64, plus 11 squared, which is 121, which gives us a total of 185. Okay. And then 12 squared, which is 144. So these are definitely not equal, so it's not a right triangle. So the question is an acute triangle or an obtuse triangle? So be careful here because if you say, well, it looks like an acute triangle. Oh, this one looks like a right triangle. Remember, you cannot trust the pictures, okay? So we have to go off our numbers themselves and see how that works. So let's see here. So we end up with a larger number with a squared plus b squared, right? So if the a squared plus b squared part is larger, so a squared plus b squared equals c squared, that gives you a right triangle, correct? Okay, that's the Pythagorean theorem. So we're looking at what if a squared plus b squared is greater than c squared? What does that tell you? And what about a squared plus b squared if it's less than c squared? What does that tell you? Okay. So if a squared plus b squared is greater than c squared, that's our current situation, right? A squared plus b squared is 185, c squared is 144. That actually is an acute triangle, okay? And you can check that out for yourself. I think the easiest way to think about that is what is a triangle you know has to always be acute? An equilateral triangle. So if all the sides are the same, it has to be an acute triangle. So say we have a triangle that is, let's make it easy and say something like 3, 3, 3. Then C has to be the largest one, but they're all the same, so it doesn't matter. So we end up with, how is 3 squared plus 3 squared related to 3 squared, right? So 9 plus 9 is 18, 3 squared is 9, so that has to be greater than, and that's the situation we have right here. All right, what about over here? So in this one, my A and B are 12 and 16, and my C is 20. So 12 squared is 144, right? So 144 plus 16 squared, which is 256, which is 400. And then 20 squared is also 400. If those are equal, then you don't have to worry about our inequalities over there. It's automatically a right triangle. And just to finish filling this in, if a squared plus b squared is less than c squared, by process of elimination, has to be obtuse. So that you can use that to make sure you know what you're looking at.